Hey everybody, it's Mr. Mott. What I want to do is go over some momentum graphs. So oftentimes we want to be able to visualize information, and we do that in graphs quite a bit. So I've got three different graphs, and I'm going to kind of go individually by each to see what do we think is happening, what type of collision do we have, and what does information tell us about the mass of the objects. All right. So our first graph on the left here, we've got cart 1 and we've got cart 2. First question says, did the carts start out together or are they separate? So kind of what we're noticing that cart 1 and cart 2, since the lines are separate from each other, they are separate. All right. Now what ends up happening is that cart 1 and cart 2, they end up hitting together and then sticking together. All right. So if they're separate to begin with and they stick together, we say that's an inelastic collision. All right, that's the sticky kind. Initial velocity of cart 1, we want to be looking in this area. And so if this is 4 and this is 6, I'm thinking that line is around 5. So I think the initial velocity would be plus 5, probably in meters per second, although it's not labeled. And then for cart 2, initial velocity, I think is right here. So that looks like about -3 meters per second. All right. In terms of which cart's velocity changed the most, let's kind of zoom in on our graph here, kind of see which one changed the most. And I'll get rid of my drawing in there. Maybe it's a little easier to see. That's annoying. All right, so in terms of which one changed the most, cart 1, it went from, if this kind of line is where they met, cart 1 only went down a small amount here. It went down from, say, 5 to 3, so it went down a quantity of 2. And then, but cart 2, it went up all this amount here. And so it went from -3 up to 3. So the change that it experienced was 6 total squares. So when we think about which one changed the most, I think cart 2 changed the most. So we could write that down, which changed the most. So I would say cart number 2. And then it says, what does this tell you about the mass of the cart? So if we think about, if we have two objects and they hit each other going at different speeds, which one is going to bounce off the most? It's going to be the object that has the lighter mass. So I think cart 2 has the smaller mass, or you could just say it would be lighter. So cart 2, I think, would have the smaller mass there because its velocity changed the most. If you have a small object hitting a big object, that big object, that heavier object, is only going to move a little bit, and that's what we saw with cart 2. All right. Since we're talking about the last square on there, it asks us about the formula. And so in terms of the formula, since they start out together, they each have their own momentum. So I'd say M1 V1 plus M2 V2. And then on the right-hand side, since they stuck together here, I would say then I would have my two masses added to each other times the velocity. All right, and that's what I would have as far as my formula. All right. I'm going to redo that, move that down here. So that would be the formula. That's what you'd kind of write in that last box below. And then we can analyze what's going on the other graphs. Okay. All right, so if we look at our second graph here, zooming in, did they start out together or separate? So again, here's cart 1, cart 2, they're starting out separate from each other. But what we notice is that at the end, cart 2 is up here. So we have cart 2 is up here and cart 1 is down on the bottom. So they start out separate, they ended separate. So when they collided, they must hit each other, and then they bounced off of each other. So the type of So they started out separate, and since they bounced off each other, that would be elastic collision. All right, that's an elastic collision. Initial velocities of these. Initial velocity of cart 1 would be at 8, and then for cart 3, it was at -3 again. All right, and that's probably in meters per second. And what else do we have? We had initial velocities, which one velocity changed the most, and then what about the mass? So again, if we look at where they ended up, so cart 1 went from up here at, oops, it actually didn't start out at 8, did it? It was actually cart 1 started out at 7, my bad. So cart 1 was at 7. And then, so how much did it change? It went from 7 to 0, and then it went all the way down to 6 here. So cart 1 made a change all the way down here, and so 7 plus the 6, it had a change of like 13 in terms of, you know, going forward and then moving backwards. And then cart 2, let's change colors here. Cart 2 went from -3 to +3, so its change was 6. So cart 1 had the biggest change, so therefore I think cart 1 must be lighter in mass. It has a smaller mass. All right. Let's see. And last one, about the momentum equation. So if it's elastic, meaning they're bouncing off each other, that means that, so we'd have the two objects are separate, so we write our M1V1, M2V2, and then afterwards the carts are still separate, so it'd be M1V1 and then M2V2. So that's your formula for when objects hit each other and they bounce off. They all retain their own momentum, even though that momentum will change. All right. The last one here we have in the graph on the right. Did they start out separate or together? Where there's only one line, so they started out together, and then they ended up, and then they separated. And so this is an explosion type of collision. So start out together and they break apart. So they start out. So that's what we have there. Velocities. The initial velocity of both of them is 3 meters per second. That's your initial velocity is at 3. And then which one changed the most? What does that tell you about the mass? So if we started out at 3, cart number 1 went from 3 to probably 5. And then cart 2 went from 3, and then it went down 3 plus another 4. So this had a change of 7. And so cart 2 changed the most. So therefore, I think cart 2 is smaller in mass. And that's kind of what it tells us. In terms of our equation, since you have an explosion, this is actually equation is opposite of the first graph we did. So since the two objects were together, we take their masses together times their velocity. Move that over here. And then afterwards, they're separate. So then I would have M1V1 plus M2V2. All right. Hopefully that helps explain a little bit about how we interpret these graphs and all the data that's kind of jam-packed in there. Thanks for watching.